Good evening, everyone. Welcome to the gatejeeneetqna NEET Q&A our channel. So, in last video we uploaded the solution on circuit question, and previous to that we also uploaded a question on SHM, that is simple harmonic motion. You can check these questions. The link will be provided in the description. So today we are again going to focus on one of the concepts which is very frequently asked in JEE and as well as NEET. So you can expect at least one or two questions definitely in such competitive exams. So the question is actually related to that force, friction. Do you remember, have you seen a question like this, that there is a table object of mass m, then a different object of mass, again different mass, they are connected through a pulley, and then we have been asked what is the acceleration, or what is the frictional force here, or what is the tension in the string. So we are today going to learn about these concepts. In the next video we'll be solving a equation, or sorry, we'll be solving a numerical on this. So let's begin. So see here, first of all, whenever you are solving a question related to such concepts, sorry, this should always be vertical. Okay, so whenever you are solving a question like this, so the very important basic concepts are, first thing, that the entire system, first you have to consider it in equilibrium. Next, so how you are going to consider it in equilibrium? So for equilibrium, always remember that all horizontal forces should be equal. The horizontal forces should be equal. So in layman terms, we can say the forces acting in opposite directions in horizontal position only. So suppose if there is an object and there are two forces acting on it, let this be horizontal force 1, this let be horizontal force 2. So for this object to be in equilibrium, when this object is going to be equilibrium, that is, it won't move, neither it is going to move there, neither it is going to move left. So for this, both the forces, that is this HF2 and HF1, should be equal. So this we are saying the first sub part. The second sub part is, see, we considered horizontal force. The next one is vertical force. So vertical force 1 should be equal to vertical force 2. So if there is an object, two forces are acting on it. So for this object to be in equilibrium, the downward force and upward force both should be equal. So this is the first condition. This is the first concept actually. And the next one is, see, if there is one string only, okay, there is only one string. So if there is only one string, so the force should also be same in the string, and the force developed in a string, generally we refer it as tension in such type of questions. And one string, one tension. So this is the next concept. If there is one string, then only one tension can be acted on it. That is, the tension acting here and the tension acting at this part both should be equal. Okay. So these two are the major concepts which you should know. Now we'll be moving on to the third part. Like, these are the just sub parts of this. Always remember, tension acts away from the object. I will just show you with this example. See, just imagine that this object is moving backwards or forward. We are just taking it as backward. This object is moving backward, suppose, by any force. You must be thinking how this object can move backward. So I'm just saying, just imagine. And what we have told, that tension is always directed away from the object. So tension is always directed, see, this is the object, so tension should always be directed away from it. Same here, tension should always be directed away from it. Why I took this direction, this backward direction? Only to say that you need not worry whether this object is moving in which direction. We have to just focus on tension, and that direction of tension should always be away from the object. Here also away from the object, here also away from the object. Okay. And the third one is friction. So this you always know, that friction is always acted in opposite direction to that of motion. Friction always acts in opposite direction to that of the motion of the object. So again, just consider this one. So if the object is moving in this direction, so now we will take a realistic case. If the object is moving in forward direction, the direction of tension is not going to change, because we have already given that the tension direction is always away from the object. Now how to say about the friction? So if the object is moving forward, so this friction will always act in opposite direction. This is our frictional force. Okay, this is our object's direction, object's moving direction, and frictional force. So always remember that this frictional force and the direction in which the object is moving should always be opposite. Okay, so this is a basic thing. Just see this, and we will solve one more question on it. Not a question, we'll just give a generalized view. I hope you are clear with this. If you have any query, you can ask us on our Gmail ID that will be posted in description, or you can always comment to us. So let us consider an example. There is a table. This is your object. Say mass M1, and this is of mass M2, connected to each other through string. Okay. Now, this is just a generalized example. Let us say that this object of mass M1 is moving in this direction. Okay, the object is moving in forward direction. So then tell me, the acceleration will also be in the same direction. So the acceleration will also be in the forward direction. Okay, now come back to the previous points. What we'll consider this first to be in equilibrium. Equilibrium means neither this object M2 is moving, neither the object of mass M1 is moving. So if this object is not moving, its downward force and its upward force should be equal. What is its downward force? Downward force is nothing but weight of the object. Weight of the object. So that will be mass into gravitational acceleration. Next is, due to this weight, there will be a force developed in the string, and that force is always called as tension. And tension is always directed away from the object. So what will be the direction of tension? This one, away from the object. Okay. Now, since there is only one string, So we have already told in the previous section that one string, one tension. Okay, but the direction of tension is directed away from the object. So again, the direction from this object for tension should always be away from the object. I hope you are clear. Don't worry about these signs that these are opposing. This is a method to solve, and you always must know that there is a force developed in the string and that should be always directed away from the object. Okay, so we consider the first object, upward force, downward force. Now here also there will be there. See, the object is moving in forward direction, therefore there must be a force in backward direction, right? So let the backward directional force be frictional force Fs. Okay. Next, again, even this object will have a vertical force, that is its weight, mass into acceleration, and an upward force, that is normal reaction. Okay, so how to solve these questions? See here. First, for equilibrium, we are considering vertical equilibrium. Vertical equilibrium for object of mass m2. So the upward force is tension and the downward force is m2g. This should be equal. But now in this question, if you see, the object is moving forward. If this object is moving forward, the object of mass m2 will obviously go downward. Object of mass m1 is moving forward. So if this object is moving forward, then this m2 will obviously go down. Okay. Now, see, first we consider vertical equilibrium, but this system is not at equilibrium. So now we'll modify this. How we are going to modify this? If you consider now here, there are two downward forces. Okay, for converting these two forces, you have to multiply it with mass. So we have two downward forces and one upward forces. So see here, this is T, M2G and M2A. What is this M2A? The force. I told you for force we have to multiply with mass. One more thing. If this object is moving downward, so which force should be greater? Obviously the downward force should be greater. That's why the object is moving downward. So how we are going to write here? M2G minus T equal to M2A. So now for those who are confused, I will say with an example. Suppose if there is a force of 10 Newton acting upward, and there is a force of 12 Newton acting downward. How we say that in which direction this object is going to move? We will say in downward direction. With what force? How we say that? 12 minus 10. So what is the basic condition here? That the greater force minus the smaller force. So here the greater force is M2G. How did we convey this? Just because of the fact that this object is moving downward. So therefore downward force should be greater. So this is your first equation, remember. M2G minus T equal to M2A. Now this one, if you see this object, again we are considering vertical equilibrium only, but now we are considering of mass m1. Now tell me, when this object is moving forward, is this object going to move upward or downward? Obviously not. So therefore the upward force should be equal to downward force. So what's the upward force? N equal to your downward force m1g. So this I've just explained for equilibrium. Now next question. Okay, so this was since object is moving downward, so therefore we wrote this equation. This is for equilibrium. Now we are considering the horizontal force over this mass m1. So what are the horizontal forces acting here? Tension and this frictional force. So for equilibrium, if you see, for equilibrium, the backward force, that is Fs, should be equal to T. But now in question it's given that this object is moving forward. So if it's all moving forward, then this forward direction should be greater. Okay, and if it is greater, so with analogy to this equation, how we should write the equation? Forward, that is T. What is the opposing force here? This backward force. So therefore minus Fs equal to, now the difference of this will lead to the motion, and for force we should always multiply this acceleration with mass m1, that is m1 into a. I will again repeat this. For first object, if the object is moving downward, downward force should be greater, therefore we wrote m2g minus t is equal to m2 into a. Now this object is moving forward, so therefore the forward force should be greater, so therefore T minus Fs equal to the object on the force, the force on the object, that is mass into acceleration m1 into a. Okay, so just if you solve these two equations simultaneously, you can get the values.